solve empirical and molecular formulas. The empirical formula is going to be a formula that the subscripts can be reduced in the formula. So there are 4 steps to doing this. The first thing you're going to do is going to give you a percent typically in the word problem. You want to cross out the percent and turn that into grams. Second, you want to convert the grams to moles for each element. We should be really good at this point. We've already done mole conversions. Step 3, you're going to divide the mole by the smallest amount. It's going to be really easy to identify that. And then step 4, the whole numbers obtained in step 3 are then going to be used for your subscripts for the formula. If it happens to end in 0.5, then you're going to multiply by 2. Alright, so your first example, what is the empirical formula for a substance that is 32.4% sodium, 22.5% sulfur, and 45.1% oxygen? So step 1, I took all those percents and turned them into grams. So 32.4 grams, 22.5 grams, and 45.1 grams. Step 2 are my mole conversions. So I set each problem up with a given. I'm going to multiply by 1 for the numerator and divide by the molar mass at the bottom. So the mass of sodium is 23 grams, and grams is going to cancel. 32.4 times 1 divided by 23 gives you 1.4 moles. 22.5 grams of sulfur multiplied by 1 mole divided by 32 grams of sulfur, because that's the mass of sulfur. Grams and grams is going to cancel. 22.5 divided by 32 gives you 0.70. And then for oxygen, 45.1 multiplied by 1 divided by 16. So then you're going to do 45.1 divided by 16 is going to give you 2.8. So that's step 2. Step 3, we're going to identify the smallest number. So of 1.4, 0.7, and 2.8, obviously 0.7 is the smallest, so each number is going to be divided by 0.7. So 1.4 divided by 0.7 gives you 2. 0.7 divided by 0.7 is 1, and then 2.8 divided by 0.7 is 4. So now we take those whole numbers and we fill it into our formula. So Na2 S1O4. So that can be reduced down to Na2SO4, because remember, anything that does not have a number there is understood to be 1. So hopefully you remember how to name this. This is sodium sulfate. So now we have our molecular formulas. A molecular formula has subscripts that have not been reduced or simplified yet. So there are 3 steps for this one. You must have the empirical formula in order to calculate the molecular formula. So in some problems you may have to solve for both, but number 1, you have to have the empirical formula, and you just learned how to do that. 2, you're going to divide the mass given in the problem by the molar mass of the empirical formula. 9 out of 10 times they're going to give you what the molar mass of the compound already is. Very rarely will you have to calculate that for yourself, but in case you do, you take the mass of each individual element, you add it up together, and that's going to give you the molar mass. But for the molecular formula, they're going to give you the molar mass of that already, because you're going to have that in order to solve for the problem, and soon you'll understand what I mean. Then you're going to use those whole numbers to multiply by the subscripts. So it's much easier than what it probably sounds. So in our example here, the empirical formula of a compound is CH2. So it means we have 1 carbon and 2 hydrogen in the empirical formula, which means this is the one that has been reduced down. Its molecular mass is 70 grams per mole. So what is the molecular formula? So step 1, we identify what the empirical formula is, that's CH2. Step 2, we have to calculate the molar mass of the empirical formula. So they gave us the molar mass of the molecular formula. So carbon has a mass of 12. We only have 1 carbon, so just 12. Hydrogen has a mass of 1 gram. We have 2 hydrogens, so 1 times 2 is 2. We add up 12 plus 2 gives us 14 grams. So now on to step 3, we have to take the molar mass that they gave us in the problem and divide by the molar mass that we calculated from the empirical formula. So in the problem that tells you that the molar mass is 70 grams, and we just calculated that the empirical formula's molar mass is 14. 70 divided by 14 gives you 5. So then you have to take this whole number and multiply it by the subscripts in the empirical formula. So 5 times 1, which is the mass of carbon, is 12. 5 times 12 gives you 60. And then 5 times 2, which is what the mass of The empirical formula for hydrogen is 5 times 2 is 10. 60 plus 10, I hope we all know, is 70. So that means that now our mass from our problem, or our new molecular formula, matches the mass that it gave us for the molar mass in the problem. So that means the molecular formula is C5H10. And notice that the two have the greatest common factor of 5 in common. If you divide 5 by 5, you get 1. If you divide 5 into 10, you get 2. And that's how we have C1H2 here. But the molecular formula is C5H10. So what you're going to do now, you have a packet. It's going to have mole conversions in the front. Then on the back, you're going to have empirical and molecular formulas. You go ahead and try this yourself. Do the best that you can. Replay this video if you need to. Make sure you use your roadmap if you need it. Good luck.